Hello, I'm Stephen Rakusik with South Dakota Public Broadcasting.
I'm Dale Droege, a professor of biology at Dakota State University.
And today we're going to dissect the sea star.
Yeah, sea star, and more commonly called starfish, but the more precise name is sea star, and they're a member of the echinoderms, probably the best known member of the echinoderms, which are an unusual group of marine animals. Echinoderms only live in the oceans.
So you want to go ahead and start?
Yeah.
Where do you start, on top, bottom?
Yeah, usually, if you're going to dissect it, you lay it so that the madreporite, the surface of the mouth is down, the surface away from the mouth is up, and the structures are repeated in the different arms, so you can open up 1, 2, 3 arms, you can open up different numbers, and then you can do different things. The only thing you want to do is try to preserve that madreporite. So let's go in with scissors, again, through that hard endoskeleton. You can hear it crunch, snap. Things are. I want to be careful. I just about stabbed myself there. And cut along away from yourself, through that endoskeleton up toward the central disc area.
And kind of a hard cut because you can't really lay it down because of the
right.
The weird angle.
You kind of have to cut up until you cut along both sides of the.
Anything to look for here as far as how deep to go?
Yeah, just kind of press up. You want to kind of press up. You can't do too much damage, but you kind of want to press up against it so that you can pull that. And then as you lift that skin off, that endoskeleton, the structures the digestive glands will come into play here. Can't do that very easily. And you want to push those down. Whoop, I didn't quite get that. There we go. There we go. Snip that off, and you can see these digestive glands, sometimes called the pyloric ceca, lay down there, and you just lift that up. Here you can see the parts of the endoskeleton. They're called ossicles. They connect together, so you can see that right underneath the skin. The things are.
What's nice here too for the kids, if they mess up once, they have 4 more times to try it.
Yeah, and this one I think we'll just cut that off for now. You can keep that off. We'll just get rid of that, and you can cut into, where's our madreporite? Right there. So we'll cut into another.
And even too, if you have, if you have 4 kids in a group, you could have each child.
Yeah, everybody could take a turn. Yeah, I think that'd be a great idea. And you just want to cut around this thing. So it's relatively easy. And I say you can't do too much damage. You just want to be a little careful when you lift things off. And right when where the arms and the central disc come together, a lot of times it'll stick right there, and so you want to make sure you kind of snip through that.
I don't know if the mics are picking up, but there's definitely a crunch in that skeleton.
Yeah,
this is an endoskeleton, you said?
It's an endoskeleton, yep. But it's right near the surface. It's called a dermal endoskeleton, or right near the skin. And so again, there's these large structures here are the pyloric ceca. Probably take a closer look at those in a minute. Now as we get up here,
kind of hold that up.
Yeah, hold that up. Now here's the madreporite. So you want to cut around the madreporite. You want to cut into the surface. You want to leave the madreporite. You don't want to take the madreporite out. I might have to hold on to him here. And so then you want to expose that central disc area.
That probably is the hardest part of the dissection, probably.
Yeah, you don't want to get too carried away. And say, in cutting around the central disc here, you want to make sure you leave a lot of space there, and then you have to cut in those margins there. And I'll leave the arms. We'll just do 2 arms for now, but like I say, you could do more.
Now on that central disc too, there's going to be some material sticking to the top of that?
Yes, exactly. And so now as we, actually I think I'll take this flap off again.
Okay.
And now as we want to lift that up, we want to be really careful here to not leave too much of the stomach behind. So as you can see.
I can kind of lift here maybe for you. Is that'd be all right?
Yeah, that works. As you lift that, I might have to use a scalpel on that. Kind of cut some of this tissue here. So, whoops.
I'll just grab it with this maybe.
Yeah, that'd be safer.
Hold the tweezers here. And this, like I said, this would be something that we're just kind of showing it for the camera view here, but
yeah, you want to be careful.
The kids would have this down and they'd be pulling it back.
Now from the stomach that I can go ahead and just clip that up in there. Yeah, there, that's central disc area off. And there's our madreporite there. Right here, and then here's these parts of the stomach. Here, actually, this one really came out well. If you look right here, this is the end of the digestive system. They look like almost like little groups of grapes. They're very tiny, little circles on them. These are called the rectal bursa, and they're actually for some digestive functions there at the end. And so that's pretty, you won't always see those and things are, but if you do see them, that's what they are right there on the end.
I don't recognize that structure.
Yeah.
It's
And
unusual.
then here, this very thin-walled structure here is the pyloric stomach. So it's a two-chambered stomach, cardiac stomach closest to the mouth, and the pyloric stomach at the other end. And since we're coming in from the top, we're seeing the pyloric stomach first. And this one's showing up real nicely. You can see these extensions here out to these digestive glands. So these digestive glands producing all of this digestive juice, these enzymes, and dumping that into the pyloric stomach there. So you can see that. So that connection shows up real nicely there. And the pyloric stomach, it rarely comes out intact. You can see how thin the tissue is. It tears.
This one looks amazing, though.
Yeah, this one actually is pretty good. So you can see that kind of a bag-like, very thin wall, structure that where digestion would be completed. Although a lot of their digestion takes place out, internal.
Would you say that maybe many of the kids might have that whole part maybe even removed?
Yeah, a lot of times it'll come off on this upper surface here. The when you pull, when you're pulling this off, sometimes it'll stick to that, and you'll look on here and you can see, sometimes pieces of the pyloric stomach. So yeah, you have to be pretty careful there. Anyway, yeah, no, that's really nice. But I think for our purposes, we'll want to go ahead and, I'll go ahead and clip these digestive glands. We'll go ahead and take these digestive glands completely out of this arm. And we'll go ahead and start to just go ahead and take some of that pyloric
So
stomach
probably
out.
like tweezers and probably, what
Yeah,
are you suggesting,
tweezers
or
and
scalpel?
scissors.
Or?
I might actually try a pair of forceps here and see if that, you want to make those breaks. And you don't have to maybe get it all, but there, see, you can kind of that's tearing away, all that thin tissue is tearing away. And what's left then, see, underneath that is a much thicker, more muscular tissue. That's the cardiac stomach, the stomach that we talked about that they shoot out through their mouth or extend out through their mouth to capture food. And so this is thicker walled. And it's actually, you'll often, when you pull on it, it doesn't resist because there are ligaments that hang on to it, because if you're going to push your stomach out through your mouth, you have to have some way of pulling it back in. So I think we can go ahead, though, and like I say, go ahead and kind of pull that back. And so there's the cardiac stomach right there. And push that back. And here's some really nice, we're going to maybe lay that flat here for just a second, and you can see, they were repurposed on that. You can see when you pull the, let me cut that back a little. When you pull the digestive glands out, right in kind of the armpit, the place where the arm and the central disc come together, you'll see these structures. These are gonads. These are reproductive structures. And starfish are actually male and female. They separate between, they have separate male and females, but it's really hard to tell the difference. You really, there are no obvious characteristics until they're actually producing either eggs or sperm. So when
external or internal reproduction?
External fertilization. The males produce sperm and the females produce eggs. They both release those into the water where the fertilization occurs, and then the larvae develop outside the body. So there's no parental care or anything like that in these species, in this group.
And as far as size, this one actually looks medium. Is it larger, smaller?
Yeah, this can be really frustrating because you'll take this open and sometimes it's very hard to see anything, and it depends upon the time of year and the maturity, the age of your starfish. So if you have some small starfish, it's the wrong time of year, those gonads can be very, very small, and they'll just look like little feathers almost in there. If you get one during the reproductive season, it can be so big that those gonads have pushed out, and they're almost pushing everything else out of there. So it really does vary a little bit. But anyway, these are really nice. These show up really well. So there's the gonad, like I say, underneath that digestive gland. So the digestive gland lays on top, gonad underneath.
How about, can I ask a question, Dale? How about these structures right here? This looks kind of shiny right here.
Okay, yeah, we can sort of get, that's part of the water vascular system. Those are the canals that carry the water out into the arms. And so we can, let's see, here's our madreporite here. And let's push that stomach all the way back out of there. Yeah, there it is, very nice. This little white tube here, a little worm-like tube, is the stone canal. And that stone canal goes up and connects to the madreporite. So water comes in through the madreporite, down the stone canal, into this central ring canal. Let me just pull that stomach completely out of there now, I think, or cut it out.
And as far as any type of circulation,
Very little. There are some vessels around this central disc area, but they have very reduced circulatory system. These animals are very strange.
so the canal you're talking about, this is salt water being brought in?
Yeah, and they have actually no excretory system at all, no excretory structures. Their tube feet do that work. So it's kind of I say they're really unusual animals that way. So here's that stone canal. And I say the water comes down, and then it goes into this ring canal, kind of on that radial plan, and from the ring canal the water runs out into the radial canals that are inside this ridge, this white ridge. And then you can see on either side of that ridge are the tube feet, the top part which is like a little bulb, almost like a medicine dropper bulb, called the ampulla. So you can see those they look like little bubbles along here. Those are the ampulla which extend down to the tube feet. So the water comes in, it's going to its tube feet. So when the water comes in and then it squeezes the ampulla, that extends the tube foot. When it relaxes, and then the muscles can swing the tube foot along, and
all those give it the strength to open up clams.
Yep. I say again, the
Sheer numbers.
concerted reaction or a concerted interaction of hundreds or thousands of those produce a lot of force. And you can see they'll crawl along, and that's how you see a starfish that just kind of glides along. It's moving along on all those little tube feet, walking along on them. So, again, so those are this water vascular system unique to echinoderms. No other animals, anything like that, has those basic parts. Again, so you look through the, pretty simple structure, but again, incredibly effective. These animals are, widespread in the oceans. They're one of the more common animals we're used to seeing: sea urchins, sand dollars, sea cucumbers, those kinds of animals. So they have kind of a different lifestyle. It's very slow. It's not a highly, there's no brain or anything, but they're very successful at what they do.
Well, thank you so much, Dale.
Yeah, I'd say very interesting. Next time you out in the ocean, you're picking up sand dollars and things, and or looking at sea stars, you can kind of appreciate some of these really interesting adaptations that they possess.
Absolutely. So you want to go ahead and start?
Yeah.
Where do you start, on top, bottom?
Yeah, usually, if you're going to dissect it, you lay it so that the madreporite, the surface of the mouth is down, the surface away from the mouth is up, and the structures are repeated in the different arms, so you can open up 1, 2, 3 arms, you can open up different numbers, and then you can do different things. The only thing you want to do is try to preserve that madra.
I'm Stephen Rakusik with South Dakota Public Broadcasting.
I'm Dale Droege, a professor of biology at Dakota State University.
And today we're going to dissect the sea star?
Yeah, sea star, and they're more commonly called starfish, but the more precise name is sea star, and they're a member of the echinoderms, probably the best known member of the echinoderms, which are an unusual group of marine animals. Echinoderms only live in the oceans. All right, so let's go in with scissors, again, through that hard endoskeleton. You can hear it crunch, snap. Things are. I'm going to be careful about stab myself there. And cut along away from yourself, through that endoskeleton up toward the central disc area.
And kind of a hard cut because you can't really lay it down because of the
Right.
the weird
Yeah,
angle.
you kind of have to cut up until you cut along both sides.
Hello. Anything to look for here as far as how deep to go?
Yeah, just kind of press up. You want to kind of press up. You can't do too much damage, but you kind of want to press up against it so that you can pull that. And then as you lift that skin off, that endoskeleton, the structures the digestive glands will come into play here. Can't do that very easily.